Last time we talked about models, efforts, and thinking. In this one we discuss streaming and why a 200 doesn't mean success. A 200 does not mean success when you're streaming. The status code is committed the moment the first byte ships, so if the platform overloads halfway through, the error has to arrive inside the stream itself. A client that only checks a HTTP status will treat that as a truncated success and never know it happened. Set stream to true and you get server-sent events in this order. Message_start opens an empty message shell, then each content block gets its own start, a run of deltas, and a stop, indexed to its position in the final array. Message_delta carries the stop reason and cumulative usage. Message_stop ends it. Ping events can show up anywhere, and error events can show up after the 200. Reconstructing a stream is mechanical if you follow the index. Message_start opens an empty shell. Each content block gets its own start, a run of deltas carrying the actual fragments, and a stop, and every one of those events carries an index matching that block's position in the final content array. Message_delta carries the stop reason and the cumulative usage. Message_stop closes it out. That indexing is the whole trick. It's what makes streaming a lossless encoding of the exact same message object you'd get back without streaming at all, which is exactly what the SDK accumulators rebuild. 3 habits that quietly corrupt state, and none of them throw. First, checking only the HTTP status. The status code is fixed the instant the first byte ships, so a midstream overload has nowhere to go but an error event inside the stream itself. Second, summing usage yourself. The usage field on message_delta is already cumulative, so adding it up again doubles and triple counts. Third, parsing a single input_JSON_delta as JSON on its own. It's a fragment of a string that only becomes valid JSON once every fragment for that block is concatenated. A client that only handles errors at the HTTP layer will treat a midstream overload as a truncated success, and never know anything went wrong. Which delta type you get depends on which block it's updating. Text_delta carries a plain string fragment. Input_JSON_delta carries partial_JSON, a fragment of a string, not a fragment of an object, because you can't represent half a parsed object. Thinking_delta carries a reasoning fragment. And signature_delta carries the encrypted signature, arriving right before the thinking block closes. Here's the trap. With display set to omitted, which is now the default on every current model, you still get the thinking block opening and closing, but there's exactly one signature_delta in between and no thinking_delta events at all. Code that waits for thinking text before it renders anything will just hang. For more traps. 1. Stop_reason reads null in message_start. It only ever shows up in message_delta, nowhere else. 2. Expect visible pauses between tool input deltas. Current models emit one complete key and value pair at a time, and that's normal, not a stall. 3. Error recovery changed at Claude 4.6. On older models you resumed an interrupted stream with a partial assistant message, but prefill is rejected now, so you add a user message instead, telling Claude where it left off and asking it to continue. For iStreamTrue is rejected inside a message batches request, because batch results come back as a file, not a stream. So, streaming is a lossless, indexed encoding of the response you'd get anyway, and the two things that trip people up are treating a 200 a success and summing a field that's already cumulative. Get both right and streaming is mechanical. Next up is the other half of that picture, what stop_reason actually tells you, and how to retry without corrupting the conversation. If clear, sensible thinking is what you are after, subscribing is the most direct way to get the next one. See you in the next video.